Okay, so this lecture we're going to talk about polarity. So when you think of someone as a polar opposite, that means that they are different, that these two people are completely different. Now, polarity in molecules means that one side may have a partial negative and one side may have a partial positive charge, and that's because of electronegativity. So polar bonds are bonds where the electrons are shared unequally between atoms. So it's bonds where maybe one atom is pulling the electrons closer to itself than the other. So think of a tug of war. If you and your friend want to do a tug of war, say your friend's stronger than you, your friend's going to be pulling the rope closer to him or herself than yourself. And that's because your friend is stronger than you. That's the same with atoms. So the atom that is more electronegative will pull the electrons closer to itself. So electronegativity is a measure of the ability of the atom in a chemical compound to attract electrons from another atom in the compound. So here we have an electronegativity value chart. Electronegativity increases as you go across a period, okay? They get stronger, and then it decreases as you go down a group. So it increases across a period, decreases as you go down a group. So you'll notice that fluorine is the most electronegative atom. Fluorine will pull electrons from anyone, whereas francium is the least electronegative. So think of strength increasing this way, okay? So the stronger the atoms, the more electronegative they are, which means that they're more likely to pull electrons to itself. So think of a tug of war. The more electronegative atom will pull electrons closer to itself because it is stronger. When atoms are different, each has a different pull on the electrons. So here's a polar molecule example. So we have HF, okay? So I'm just going to go ahead and draw all these structures for time's sake. But here we have hydrogen fluoride. So fluorine, like I said, is the most electronegative element. So what's going to happen is that fluorine is actually going to pull the electrons towards itself, okay? It's stronger. It's going to pull the electrons away from hydrogen. What that does is it makes fluorine to have a partial negative charge. And that S-looking thing means partial, okay? It's not fully negative, but it is partially negative because fluorine's going to have a higher electron density on itself because it's pulling electrons closer to itself. Whereas hydrogen is going to have a partial positive. It's not as dense with electrons because the fluorine is pulling its electrons. And so this is what makes a polar molecule, is that one side will have this partial negative, one side will have this partial positive. So the shared electrons are held closer to fluorine because it is more electronegative. Okay. Now a nonpolar bond is when electrons are shared equally between two atoms. And this occurs because the atoms have the same pull on the shared electrons. They have the same electronegativity value. Now, atoms that are the same have the same electronegativity value. Just like if you cloned yourself and you play tug of war with yourself, y'all would have the same strength. Whereas here, if you have two different elements, you may have similar strengths, and so it won't cause much polarity. So here's a nonpolar example. We have H2. We got two hydrogens. They're both the same element, so they're going to be pulling their electrons equally. So there is going to be no partial charges on a nonpolar molecule. Okay, no partial charges because they are the same element. So, and both atoms have the same electronegativity value. Another example, though, is carbon tetrachloride. Okay, so we have carbon tetrachloride. It's carbon surrounded by 4 chlorines, okay? Now, even though carbon and chlorine are two different elements, what's happening here is that it is surrounded by chlorine. And so even though carbon and chlorine are different elements, it's this carbon, the central atom, okay, this central atom is surrounded by chlorines, which are all pulling the same way. Okay, so it kind of cancels out. So all atoms surrounding carbon are the same. Therefore, the electrons are shared equally. So this would also be considered non-polar because they are sharing the electrons equally. So how do you know if a molecule is polar or non-polar? Well, different atoms around a central atom will always be polar. Now, same atoms around a central atom is non-polar. So if you have different atoms around a central atom, polar, same, non-polar. So here's two examples. So we have, again, our examples of H2 and HF. So we have two hydrogens bonded together, same electronegativity, so that's going to be nonpolar. Whereas HF, two different elements, different poles, polar. Here's another example, CO2 versus COS. So CO2 is going to have carbon surrounded by two oxygens, whereas COS is going to have carbon surrounded by an oxygen and a sulfur. So CO2, since they are both oxygens, they're pulling equally on those electrons. That's going to be nonpolar. Whereas COS, you have two different elements surrounding that carbon, so that's going to be polar. Now, H2O and NH3 are a little different, okay? So we have H2O and we have NH3. Now, you say, well, both of these are surrounded by the same molecule, so they must be nonpolar. But there's one more thing we have to take into account. We have to take into account that this oxygen and this nitrogen, they have unshared pairs. And so it says, picture the unshared electrons as a different atom. So if the central atom has unshared pairs, then it is polar, okay? Automatically polar. So if there are unshared pairs on the central atom, it's going to be automatically polar. This next example is CH4 and CH3Cl. So we have CH4, and then we have CH3Cl. Okay, so 3 hydrogens, 1 chlorine. Now CH4 is going to be nonpolar because, again, all the same elements surrounding carbon, whereas CH3Cl is going to be polar because chlorine is much more electronegative than hydrogen, so chlorine is going to be pulling those electrons unequally. Now CH2O is going to be a little different. So remember the CH2O structure is trigonal planar, okay? Now they're all surrounded, the carbon is surrounded by oxygen and hydrogens. That oxygen is pulling the electrons closer to itself differently. And so what's going to happen is it's going to end up being a polar molecule. So although exceptions exist for this class, planar will always be polar. Okay, so that concludes our polar, nonpolar lectures. And so now next class we're going to talk about intermolecular forces.